Hello and welcome to this vSuite version 0.3 video tutorial. And in this video tutorial I'm just going to cover how to do a lighting analysis with the LiVi component of the vSuite. The LiVi component of the vSuite uses a program called Radiance, which is a very popular and pretty accurate lighting simulation engine. It uses Radiance in the background to allow us to calculate things like lux and daylight factor and useful daylight illuminance, etc. So I'm just going to run through very quickly how to do a lighting analysis with LiVi. So I'm just going to very quickly model a very simple room. I'm not going to cover how to do modeling in Blender. There are loads of resources on the internet about that. It's quite a large topic in and of itself. So I'm just going to do the very basics of creating some geometry for a lighting analysis. Remember that positive Y in Blender is north. So I might create a window here on the west face of the building. I might also create some kind of skylight. Like so. So this window faces towards Y, so that window will face north. This window down here will face west. So the geometry can be as complex as you wish it to be, or as close to the situation that you're simulating as you want to make it. But I'm just keeping it very simple here, just plain geometry, just to keep the video quick. And simplicity in geometry does also mean simulations run a bit quicker as well. But I have geometry, and I have two surfaces within the geometry that I want to be windows, this one and this one. So with this material, with these faces selected, I'm going to create a new material slot for the object. I'm going to assign that slot with this button to the faces I have selected. And I'm going to have a new material, and I'm going to call it glass. And this material down here in the vSuite material panel should then be changed from plastic. These are the sort of material descriptions that Radiance, the back-end engine, understands. And we're going to change that to glass. So Radiance will now understand those surfaces as being glass. For the other faces within the model, we just want that to be a standard sort of light grey wall color. So I'm going to add a new material slot, assign that slot to these selected wall faces, create a new material, call that walls, and for the walls I can simply keep it as plastic for now. That's fine. So a very simple geometry for a lighting simulation has already been created. What I can do is I can just change the color. If I just switch to my Blender render engine for a moment, I can just change the color of those glass surfaces just to signify where they are. So now that my geometry and materiality in a very basic way has been set up, I can now create the nodes to do a lighting analysis. So we're going to require a VI location node, as we always or very often do, but I also want a couple of export nodes. I want a LiVi geometry export node, and I want a LiVi context export nodes. The LiVi geometry node will convert this Blender geometry into a format that Radiance can understand. And the LiVi context node is going to create a radiant sky and a simulation context for the overall simulation. So the LiVi geometry node has a few options. If we set up an animation in Blender, then we could get the V-Suite and the Radiance simulation backend to calculate results for each frame of that animation. But I'm not going to do that here. I'm just going to leave that turned off. We can also select for our sensing geometry whether we choose vertices or faces as the points of interest in that sensing geometry. Now that I've seen that menu item, I have remembered something very important, in that we do need to create a sensing plane upon which our lighting metrics are going to be projected. So I'm going to create a new plane, put that slightly off the floor, scale it up to almost the floor size, and as we did for the shadow study analysis, I'm going to subdivide that plane so that we get lighting metric results at each point within the sensing plane. And it's basically up to you how many times you subdivide that plane, what resolution of results you want. But as you can imagine, as we increase the number of points within this plane for the lighting calculation, our simulation time will go up. Once we have created the geometry of the plane, again, we want a new material slot for that object, and we want to create a material within that material slot, which I'm going to call LiVi Sense for now, and change that from geometry to LiVi Sensor within the V-Suite Material tab down here. So, okay, I think I've got my building geometry. I've got the materiality of that building geometry. I've got a sensing plane within my building. So I can now press Geometry Export. And now that whole scene has been converted into Radiance format and is stored within this node. I need to do the same with context. Context does require a VI location node to provide latitude and longitude, which can either be specified manually or can be extracted from an Energy Plus weather file. And we can specify in here what sort of context of lighting, what sort of lighting context we want to simulate. So this is new in version 0.3. Before I had 3 different LiVi nodes to define different contexts. Now the basic, the compliance, and the CBDM context are all contained within this single node. Basic being for the calculation of lux, illuminance, daylight factor, irradiation. Compliance is for checking against some internationally relevant sort of lighting standards. Code for Sustainable Homes and BREEAM, the 2 UK standards, the ones currently supported. And CBDM, climate-based daylight modeling, where we can calculate some annual lighting metrics like light exposure, or daylight availability. But I'm just going to keep that as basic at the moment. Another new feature of version 0.3 is that instead of having to do a simulation for illuminance and a simulation for irradiance and a simulation for daylight factor, where it's actually a single metric or a single value that we can calculate, and then it's just a sort of conversion of that value into these other values. They're now clumped into one menu item. So this now selects illuminance, irradiance, or daylight factor, and we can choose which one we actually display with our display menu later on. So we can pick what kind of sky we want: sunny, partly cloudy, daylight factor sky, etc. And another new feature of version 0.3 is that when we manipulate the context within this LiVi context node, if that context involves a sun, and obviously for a sunny sky it does involve the sun, we get a live update of where that sun position will be relative to our scene in the Blender 3D view. Again, we could turn on animation, so if we wanted to have results for each hour or each sub-hour time step over the course of the day, we could do that, but I'm going to leave that turned off for the moment. And we could turn on, or we can change turbidity here, sorry, which basically controls how polluted the sky is. 2.75 is a default value for that. And we could choose to create a panoramic high dynamic range image of that sky if we wished. But that takes a little bit of time, so I'm going to leave that turned off for the moment as well. So I'll press export, and the node goes grey to now signify that it has a valid exported context stored within it, which is in tune with our menu items. If I was to change a menu item, the node will go red to signify that the stored values no longer correspond to our selected values. But if I go back to basic, which is what I had when I exported the context, it should go grey again. So I now have a geometric context, and I have sort of a surrounding sky context. So now I can add an analysis node, a LiVi simulation node. And you'll notice that that LiVi simulation node, I might just expand this window for a second. This LiVi simulation node has a geometry in socket and a context in socket. And once those are connected, I should see some options appear within this LiVi simulation node. Photon mapping is to turn on Radiance's new advanced photon mapping capabilities. But I'll probably cover that in a different video tutorial, so I'll leave that turned off for now. We can control the accuracy of the simulation. Simulation time will go up as we select higher accuracies, but our results will be more representative of a real-world scenario as we turn on more accuracy as well. So we also have here two buttons, a preview button and a calculate button. A preview button will, from the point of view of Blender's camera, which is pointing here at the moment, but I might just manipulate that camera a little bit just to zoom out of the scene slightly. From the point of view of Blender's camera, we can preview the scene from the perspective of Radiance. So if I press that preview button, we should see a new window open up. You'll get a window like this on Linux and Mac. It's a slightly different window on Windows. But we can see, if I modify the exposure of this image, we can see our building from the perspective of Radiance, and very similar to the perspective of our Blender camera shown in this window. So this isn't primarily intended for visualization. It's primarily intended to check that the material designations that you want in Radiance are the ones that Radiance are seeing. So this is just a check of kind of geometry and materiality as seen by Radiance. So I'm just going to quit out of there. So everything looks okay from, I might even look at that scene from a new camera perspective, preview that just to make sure that Radiance is seeing my glass materials as glass materials. So we just wait for that scene to resolve itself a little bit better, and it looks like our windows are being seen as windows. So that looks fine. So I can now press calculate, now that everything within the Radiance description looks fine. And that takes a little while, unfortunately, at the moment, because this calculation process is so embedded with Blender. the Blender interface does lock up at the moment while LiVi is calculating. Or more accurately, Radiance is calculating in the background. In future versions, I'll try and bring up at least a pop-up window to give some estimation of how much longer the simulation has to take. So in a very similar way to the shadow study analysis, once the calculation is completed, we have a Radiance Display button appear here in the v0.3 Display tab of the 3D View Properties panel. And if I press that, our results have now been visualized. We can't see them because they're within our building. So if I just turn my building to wireframe mode, we can now see the results of that Radiance simulation. In terms of Lux, we have Lux selected at the moment. Now we can change from Lux to Irradiance. Oh, let me just turn that off a second. We can move from Lux to Irradiance to Daylight Factor with this metric menu here, which will only appear when we have different metrics to display for the single calculation that we did. But because illuminance is similar to irradiance and daylight factor itself is just a measure of illuminance, we can switch between these three metric types. But obviously daylight factor, which is calculated underneath the daylight factor sky, and we didn't pick a daylight factor sky here, we picked a sunny sky, isn't particularly valid within this sort of context, but we can pick it if we wish. But we're more interested in illuminance at the moment. So we see that we can turn on our legend display, and that legend display will relate values of illuminance to the coloration of our results plane. We can, if we wish, change the legend scaling by either moving our mouse wheel up and down at either the bottom or the top of our legend display. And we can change those values manually here as well. I can change the scaling from log to linear. Log is good if I have very, very high levels of lux, maybe 50,000 lux on part of my results plane, and I have very low values in another part of the results plane. A log is a good way of sort of compressing the coloration of the values a little bit. But linear is fine for me at the moment. It appears that nowhere on my results plane am I getting any direct sunshine, and that's understandable because my light is coming from this part of the sky. My direct sunshine is coming from this part of the sky, but I only had a window here on this facade, and I had a window here on this part of the geometry. I'll see that a bit clearer if I turn on a more complete wireframe display. Here's my upper window, here's my side window, neither of which is getting any direct light from the sun. I can choose whether or not to have the wireframe turned on or off for my selected geometry. In this case, if I've got the results plane selected, I can turn off or on the wireframe display. As I had 3D display turned on up here, when I press Radiance Display, I can sort of three-dimensionally project those results within my scene, and the level of projection is related to the value at that particular point. So we can see quite clearly that next to this window, this west-facerly window, I have much higher levels of illuminance landing on that point. I'm not seeing very much effect from this window up here, but I might see more effect if I turn on a higher level of accuracy here, which then predicts a greater number of bounces of light moving around the scene. What other options do I have here? I could turn on the transparency or change the transparency of that results plane in case I want to see some results behind it or some geometry behind it. And I can also turn on numerical point visualization in the same way that I did for my shadow study analysis. So I can see numerical results for each point. As I had vertices selected here as my result point, I can see these numerical values for each vertex point on my lighting results plane. And I can turn on whether it's only the selected object that displays those results and whether I only turn on the visible ones. And bear in mind, if I'm outside, even though my building's displayed in wireframe, if I'm outside my building and the results are inside, the vSuite will consider those results to be invisible and actually have to move inside my building to be able to see those results. Those are the main options available. But obviously now that I've got my geometry set up, it's very quick to now, for example, make a change. So I might say, I want to see what the effect of having a much smaller window is. So I can narrow that window down. So if I just put that building back into, I've now got a much narrower window. I might say I'm a little bit concerned that this window isn't producing that much light in my scene. So I might just create a new window in here. And again, within my material tab, I want to assign the glass material to that new face that I've created. And I might change the position of the sun as well. So now that I've changed or made some changes to the geometry, within the geometry node, I need to repress export. And if I want to have that sun coming around in the afternoon to the west, so it should now shine into this westerly facing window, I can change that and repress context export. So I can simulate again, and yes, that will take a little while to calculate, but we don't have too many calculation points and the geometry isn't that complex and we're on a low accuracy, so it doesn't take too long. And if I make my building wireframe again and Radiance Display, I can now see, yes, very distinct, very high level lux values where the sun is just coming in through this westerly facing window and the sun is just coming in through this window and direct sunshine is landing in this corner of the room. So if I was to 3D level that, you can see we have very, very strong luminance levels here, not much anywhere else. I can switch it to log because now I have very different values and I can get a slightly better coloration of the result plane in its entirety that way. So, and all the other options are the same as before. So it's pretty quick to make geometric changes or material changes, or indeed set up a Blender animation of those changes, and then see those results from a lighting perspective appear quite quickly. I think that's basically everything I need to cover. Okay, thanks for watching.